Right, so let's take a look at paper 1, 2016. And this is going to be question 5, okay? The first 5 numbers in a pattern of numbers are given in the table below, 13, 15, 19, 25, 33. Right, follow the pattern in the table above to write the next 3 numbers into the table. So what's going on? We're going up, we jump up 2, then we jump up 4, then we jump up 6, then we jump up 8. So the next one we're going to jump up is 10, so that's going to be 43. Then we're going to jump up 12, and then that's going to give us 55. We're going to jump up 14, and that's going to give us 69, is it? I think so. Okay, that was a bit weird. That they just got you to without any kind of scaffolding, but anyway, yeah, that's it. So that's our pattern. Okay, so that's question A dealt with, or A part 1 dealt with. Use the data in the table to show the pattern is quadratic. Okay, so we will then go maybe, I don't know how you would do that down here, but certainly what we would do in class is we would take a look at second differences, and we would spot that we have a common second difference there of 2. So you want to put in some note, common second difference of 2, and then therefore quadratic. Okay. Find the values of B and C. Okay, so what that is asking us to do effectively is use our system to crack what the quadratic pattern, or what the formula for the quadratic pattern is, what Tn is. Okay, and we know that Tn takes the form an squared plus bn plus c. And we know that A is always equal to second difference over 2. So A must equal to 2 over 2. So A must equal to 1. And that agrees because our A is over here. So they actually kind of told us that in the question. But no harm in doing it anyway, okay? So our A is 1. We now know that T1 therefore must equal 1 squared plus b times 1 plus c, because we put a 1 into each of these n here. Okay, that's T1. But we also know that T1 is equal to 13. So we know that 1 plus b plus c is equal to 13. So therefore b plus c must equal to 13 minus 1. So b plus c must equal to 12. That's quite handy. We do the same thing for T2. So 2 squared plus b times 2 plus c is equal to, and this time T2 is equal to 15. That must be 15. So therefore 4 plus 2b plus c is equal to 15. So 2b plus c must equal to 11. I'm after running out a bit of space there, am I? So what I'm going to do is I'm going to shrink this guy over here because he was kind of unnecessary, but we stuck him out anyway. So I'm going to put him to one side. Okay, and then I'm going to work down here just to kind of maybe get a bit of coherency. I'll move this guy to that side. So that can be very confusing. It is. Where was he? He was in there, was he? Okay, so I'm going to work myself over here. So I have two equations. I have b plus c is equal to 12, and I have 2b plus c is equal to 11. Simultaneous equations. The c's will kill each other off if I change the bottom one to a minus. So I have b minus 2b is minus b is equal to 1. So b must equal to minus 1. And then c, well, to get c, I'm going to use the top equation. So I'm going to go minus 1. Ooh, something nasty happening there on my screen. Sorry. Ooh, computers, they'll never catch on, will they? So we're going to have, I'm going to use the top line here. and I'm going to go for minus 1 plus c is equal to 12. So c must equal to 12 plus 1. C must equal to 13. And that then gives me the formula. Now that's the question answered, okay? You would walk away from it at this stage. Yeah, but I'm just going to check my answer by maybe taking a look at it. So I now know that we have the formula n squared minus 1n plus 13, and that's Tn. So I'm going to check this for maybe T, what was the highest one I had there? T8. So T8 is hopefully going to be 8 squared minus 1 times 8 plus 13. And I put that into my calculator, and that gives me 64 minus 8 is 76 plus 13 is 79, 89. I think that's 89, I think. What do we have here? We had 69. Are we out there? 8 squared minus 8 plus 13 equals 69. Yeah, we're good. Sorry. Miscalculated. So yeah, we're perfect. Okay, so but anyway, the question finished when you got this answer here, okay? So do not check your answers in your exam, okay? Unless you've loads of time at the end. Yeah, move on to the next question. Keep getting marks. Keep getting your attempt marks, okay? So that's part B dealt with. Part C next. The table below shows the first 5 terms of an arithmetic sequence. Find an expression for Tn, the nth term of the sequence, hence or otherwise find the value of T30, the 30th term. God, lads, this was a long question. The table below shows an expression for Tn, the nth term of the sequence. Okay, so Tn. So we're going to use the formula A plus n minus 1 times d. And Tn is going to equal to that. Because it's an arithmetic sequence, we're allowed to use that formula. And that formula is... Sorry, I'm on the other side of my office, so just getting my tables book. Okay, I'm back. So, I don't know what that sounded like, but anyway. What page would this be on? So we're going to take a look at page 22. And because we have an arithmetic sequence, we're allowed to use the formula A plus n minus 1 times d. And it tells us that A is equal to term 1 and d is equal to common difference. So T1 for us is equal to 12 and d for us is equal to 2. Because the common difference is 2 each time. Okay, so I didn't just bang it into the formula. Tn is equal to 12 plus n minus 1 times 2. So Tn is equal to 12 plus 2n minus 2. So Tn is equal to 10 plus 2n. And we can check our answer by looking at T5 is equal to 10 plus 2 times 5. T5 is equal to 30. Sorry, not my day for arithmetic, is it? 10 plus 10 is obviously equal to 20. Okay, so T5 is equal to 20. So, yeah, and that matches up here perfectly. So that's how I knew I was going. That's how I knew I had gone wrong. So T30 on the next line. Anyway, same rule applies as last question. The question ends there, okay? Right, T30. So we have our formula. Tn is equal to 10 plus 2n. So T30 must equal to 10 plus 2 times 30. So T30 must equal to 10 plus 60. So T30 must equal to 70. And that's question 5 dealt with.